to extract information from a public display. And a very powerful framework for this kind of public interaction is based on proxemics. So we can use the more primitive body signals such as proximity to adapt the display content. For example, in this work by Ballendat, the display, the information depth is adapted on the proximity of the display. So, and I want to extend this framework by introducing foot interaction. So, one of the previous works for detecting foot positions is called gravity space, which was also talked about in a previous talk here, and it analyzes the pressure distribution of the foot positions on the floor to infer to how the body is positioned, and so yeah, yeah. So in my work, my work is motivated in actually in interpreting foot positions, because actually our foot position is kind of a language. So it's based on a psychological study where actually when we have a human-human conversation, our foot position actually expresses our focus or our interest in the conversation. So here you can see that the person who all the guys here are interested in is they are pointing with their feet on. So I'm going to try to deploy this with public display interaction. And I'm going to question, can we use this information to understand why is this person interacting with it, and therefore show make a more interactive display. So first I developed a foot tracking system, which is based on a single laser scanner that detects the object, which is the feet in this case, and extracts the features from the feet. And because we're interested in orientation and positioning of the feet, we can describe a foot position uniquely in a 6-dimensional space. And so I'm going to observe this information. And what in a first study, in a first observational study, I used an information display that shows two types of contents, so informational content and entertaining content. So we have two types of interaction sessions: informational interaction and casual interaction. And I logged the foot position data. And so with this, I got 115 foot positions labeled with the type of interaction session. And actually, you can predict with just observing the foot position in this 6-dimensional feature space, you can predict with 84% what they're going to extract, what kind of information they're going to extract from the public display. And so the foot position is actually a really informational, actually gives information about the user before he actually interacts with the display. And to give you a little bit more of an idea how the data looked like, so if users extracted actual information, the foot positions pointed more towards the display, whereas in casual interaction it was like more oriented way. So in this graph on the right side you can see the angles of the left and the right foot. You can see it's quite separated just already by the angle. So in a second study I tried to use this foot position model to actually create an adaptive interactive display. So and what I did, or how I designed the system, is I replaced the initial touch interaction with the foot classifier. So I basically used the foot position model that I found in my first study and showed them directly the content that based on the types of user that I recognized through the foot position model. And therefore I hope that the user is going to be getting the information more interactively. Yeah. So basically, in this design, the user approaches the display, and as soon as the system recognized the foot or logged the foot position, the appropriate content was shown. And the results were, and I collected results from another 27 users, where 14 people were actually extracting information, and their interaction time was reduced from 10 seconds in the non-adaptive display to 8 seconds. So that suggests that the interaction was actually more efficient, and which probably people who are in an urgent need of information or just passing by, such a system can be more useful than just a static touch interaction. And on the other side, in casual interaction, 13 people were classified with casual interaction. Their interaction time significantly increased to 19 seconds from 10 seconds, which should suggest that they were more, probably their attention was gathered. So by showing them immediately, okay, the system is interactive, the system has some entertaining content, they might be actually more interested. So, and I also asked users how they thought the content was adapted, and actually 24 out of 27 people thought it's due to their proximity. So people are actually aware of proximity, but not aware of their foot position. So that's kind of interesting, especially for public displays where people might want to maintain some social role. They try to behave appropriately, but they don't think about their foot positions. So that's why foot positions can be actually useful and beneficial in interactive information display. Okay, so having contributed this foot position as a new modality and this foot detection system, you can create more adaptive information displays. And I introduced foot positions as a new, more subconscious design factor for interactive displays. And in the future, I'm interested in using this, these findings for further, for example, evaluating public displays. We've seen gaze tracking as a useful tool in the previous talk. We can use probably also foot positioning to understand people's behavior in front of displays better. And also we could probably combine those two or some other modalities. Yeah. Thank you very much.
Thanks a lot, Bernd. So we actually have time for questions, and we have. Yeah.
Thanks a lot. Very interesting work. I wonder how this. I mean, if you have a multi-user situation with multiple people, like a group in front of the display, then you might have the display like a social actor, but then you also have the proxemics and affirmations inside the group. And I wonder if you have already some insights in how this might interplay.
That's an interesting future work. I had some of the sessions were with multiple people, but I filtered them out because it's more difficult to track them and also to understand their behavior because they might interact, as you said. Yeah. So, thank you.
Really good work. What do you think? Could you extract also gender or age by this information? Because this could be even more interesting for the advertisement.
Spontaneously answer probably yes, because of the shoes types women and men have. But so yeah, I think that's also interesting future work. Yeah.
Hi, Paul Marshall from University College London. I haven't read your paper yet, so it might be in there, but I was wondering if you've read Emmanuel Shegloff's stuff on body torque. So this is the idea that you can kind of represent different intentions with both the top half and the bottom half of your body. So your bottom half sort of represents your main focus of interest, whereas if you kind of turn your body, then that can represent a sort of temporary focus of interest. And When we were carrying out studies of a tabletop interface in a tourist information center, we found it quite useful for thinking about, so people there were certainly interested in getting information and they weren't necessarily casual users, but they would stop kind of side on to our table, which didn't mean that they weren't looking for information. It just meant that they didn't necessarily know that they were going to get that information from our table because they didn't quite know what it was. So in those kinds of complex real-world environments, I'm wondering if you do need to have more than just the kind of foot tracking, because I'm not sure that that's necessarily a very good representation of exactly what it is that the user group would be looking for. Sorry, that's slightly rambling.
The way I used foot positions was in the initial pose they had in front of the display.
Yeah.
So
what we would see would that people would start like this, they would turn, and then they'd realize that this was something that was interesting to them.
Exactly.
And then they would turn like this. So it wasn't their initial pose that was important, it was how their interaction kind of unfolded, and then they were kind of sucked into interacting with the system. So I wouldn't look at just that kind of snapshot. I would look at how it kind of unfolds over time and see if you can do something with that.
Okay. Yeah.
Thanks.
That's great. Thanks.
Hi, Alexandra Joong, Hasso-Plattner Institute. I was wondering, so you said that people thought the display was adapting like due to their proximity to the display, but do you have any more qualitative data if they kind of liked the type of adapting? So did they think this was the right content you were displaying for them?
Well,
because you can
I asked
conclude
them
that from proximity, right?
Okay, I asked them also if they found the system useful. They did not find it not useful or annoying, so at least it was not negative. So
Okay,
if that
but
helps.
what did you ask? Like, what was the question? Did you ask them what their goal was, what they wanted to see on the display, and then?
Yeah, I also asked
saw-
that as sort of verifying my foot position model. That's true,
Okay.
but just to check if the system was not just annoying, that it just changed the content.
Okay.
That was actually not the case.
And I guess this is then in the paper.
Yeah. Right.
Okay, great. Thank you.
Thanks.
Thanks a lot, Bernd. And well, unfortunately, that was the end of the session. I hope you all go get some nice lunch, and thanks for coming.